Good morning and welcome back to Math 098. For today's class, we are actually going to move into the next set of word problems that we need to dissect, and that is simple interest problems. We're actually going to work through those in two variables, which is very exciting. Before we actually updated the guided notes and updated the material, you would learn simple interest in one variable and then you'd learn it again in two variables, and I just found that to be excessive. So I decided that when we first saw simple interest, it would be, there's one account and you're just trying to find either interest or principal or rate or time, right? This time, when we see simple interest problems, we're going to have two accounts. And generally speaking, you don't know how much money was invested in either account. So we're going to be given just enough information that we can set up a system of equations and use either substitution or elimination to solve and be able to answer that question. Okay? So let's take a look. I'm going to show you the setup in terms of the graphic organizer. So think back to distance, how we had our graphic organizer set up where it was rate then time then is equal to distance. So rate times time is distance. This is going to be a similar format, but we know that principal times rate times time equals interest. So we're essentially setting it up to look the same and to kind of feel the same. It's just a little bit more expansive because we're talking about dinero, okay? So let's take a look at the notes and see how it goes. So simple interest problems. Notice the setup here. We're always going to have account 1 and account 2. You're always going to be working with two accounts in this particular class. So we have account 1, we have account 2, and notice we have a total row. This is always going to be here as well. Keep in mind, we are trying to take into account the total amount of money we're investing and maybe the total interest that we earn, etc. Good morning, Wada. Okay, so any of those things we need to keep track of. Notice your column headers, principal, rate, time. I inserted ones here for time because generally speaking in this class, we're going to be investing money for 1 full year. And then finally, your last column refers to interest. Notice what I've written here. You should only place in the interest expression you obtain by multiplying the principal, the rate, and the time for each respective account. So the information that goes here is the interest earned from account 1. The information that goes here is the interest earned from account 2. And then the information that goes here is the total interest. Similarly, we'll generally be given the total principal as well. And what we won't know is the amount of money invested in the first account and the amount of money invested in the second account. Now, notice the setup for interest equations. We have the principal for the first account plus the principal of the second account equals total principal. That's always going to be your first equation. Then you have the interest from the first account plus the interest from the second account is equal to total interest. The only time this will change is if we're told that the interest earned was the same. And if the interest earned was the same, I'm going to write this down. So if the interest earned is the same, then instead of interest 1 plus interest 2 equals total interest, it'll actually be interest of the first account is equal to the interest of the second account. That's the only difference here. Okay? So keep that in mind. You'll still have that first equation where your principals will be added together to equal total principal. But if they are the same interest, you're just going to set them equal to each other because in math, same means equals. All right, let's give this a shot. A person invests $8,000 for 1 year. Right off the bat, recall that investment is the same as your principal loan amount. So right above invest 8,000, I'm going to write a capital P so that we note that it represents the principal. for 1 year. This is time, but we already knew the time was going to be 1 year for these word problems in 098. Part of this amount is invested at 2.65% simple interest. So 2.65%, that's a rate. It's one of the rates. It could be the rate for account 1. It could also be the rate for account 2. That totally is up to you. So I'm just going to say that this is the rate for account 1. And the rest is invested at 3.12% simple interest. So again, this value here represents the rate for account 2. If the total interest in both investments is $235.50, this is total interest. It's always helpful to label. Find the amounts invested at each rate. So we do not know how much was invested in each account. Okay, so that's the important piece. Find the amounts invested. That's what we're looking for. So let's set up our chart. We've got principal, rate, and make your chart kind of small if you can, because we're going to need the room to do all the math, and then interest. I'm going to turn the page as usual just to make sure that these look good. We're going to have 3 rows. We're going to have account 1, account 2, and total. So account 1, account 2, and total. There's our awesome chart here. We are told that a person invests $8,000. Notice that we don't know how much was invested at each rate. We're trying to figure that out. So because I don't know how much was invested in the first account, I'm going to call that A. Because I don't know how much was invested in the second account, I'm actually going to call that B. What I do know is that I invested $8,000 total. So the total principal is going to be $8,000. Next, we know that the time was 1 year, so we are able to write 1 in each of those spots, just like we have in our framework above on this page. And then let's write out the rates for each account. Keep in mind, 2.65% must be turned into a decimal. So as a reminder, 2.65% turned into a decimal means you move the decimal 2 places to the left. So it's 0.0265. And then 3.12%, move the decimal 2 places to the left. Wow, my writing's like garbage today. Sorry about that. So it's 0.0312. One of the biggest places where students will make mistakes are in the actual percentages, right? If you don't write down the percentages correctly, then your entire problem is incorrect. So you want to be really careful. I would actually advise you to go a little bit slower. Make sure that everything you write matches up. 2.65%, 0.0265. If you're ever wondering, shoot, what is it again? Do you move to the left? Do you move to the right? Well, 2.65%, you're going to type that in. Just press divided by 100. And then that'll give you the actual decimal value. Okay, so that's another way to verify that you're doing this correct. Divide by 100. Now, we are also told that the total interest is $235.50. So that's going to go here, $235.50. Beautiful. Now, the only pieces that are missing are the interest for account 1 and the interest for account 2. Well, think of this logically. Interest is equal to principal times rate times time, right? So if we want the interest for only account 1, wouldn't it make sense to take its principal times its rate times its time? Yes, Hannah. So what we'll actually do is we'll write it so that the coefficient comes first. So A times 0.0265 times 1 is the same as 0.0265A. We'll write the coefficient ahead of the actual variable. For account 2, the interest is principal times rate times time. So same thing, 0.0312b. Now that our chart is completely filled out, let's take a look at our two equations. The setup for interest equations are as follows. The principal of the first account plus the principal of the second account equals total principal. There it is. So I'm going to circle that. So let's write out that our first equation is A plus B is equal to $8,000. If we look back at the setup, we see that the interest for the first account plus the interest of the second account will equal total interest. So our next equation is right here. So carefully, again, this is the part that can get confusing if you don't write it exactly as you see it. So we have 0.0265A plus 0.0312B is equal to 235.50. Good. Now, here's the interesting piece. I'll go back in just a second. Typically, you can solve this by substitution, right? If you choose to use the substitution method, please solve for either A or B in the principal equation, okay? You want to solve for either A or B in the principal equation and then substitute that into the second equation, your interest equation. That's the best approach. I'm actually going to use elimination. Like I said before, I prefer elimination. And I think once you see it, you may say, yeah, that's kind of nice. They're both in standard form. So we might as well multiply by the opposite coefficient to eliminate the variable. So I'll show you how I would do it. And as always, for our second example, I'll use substitution just to show you exactly how you can do that. But remember, you have your choice. It depends on your style, okay? So in order to use elimination, I'm actually going to say that I want to eliminate A's, okay? Notice that I have a 0.0265. So the opposite of a positive 0.0265 is a negative 0.0265, right? Okay, so I'm going to take this first equation and I'm going to multiply it by a negative 0.0265. As always, we're going to distribute. I hope this idea of multiplying by the opposite makes sense because we've seen this before, we just haven't seen it in terms of decimals. That's the biggest thing. But I don't want that to throw you off. So as always, we're going to shift to the right on this page. So negative 0.0265 times A is negative 0.0265A. Negative 0.0265 times B is a negative 0.0265B. Careful when you write this out. Double check that everything you're writing matches. And then negative 0.0265 times 8,000 is a negative 212. I'm going to shift over. There we go. The second equation, I did not have to multiply by anything because my coefficient is the opposite. See? They're exact opposite. So I don't have to multiply the second equation by anything. I simply just have to write that second equation directly underneath. Carefully. All it takes is one digit written incorrectly to change your entire answer. I'm going to shift this over a little bit more. Notice that my terms with A's are opposites, so they're going to cancel each other out, leaving you with a 0. Now, carefully punch this in exactly as you see. Negative 0.0265 plus 0.0312. That gives me 0.0047b is equal to, now take the negative 212 and add the 235.50. That'll give you 23.5. Okay? Yes, double check your work. Make sure everything is written correctly. Next, Hannah, next we're going to divide by 0.0047. And actually, I'm going to double check. So we've got, it is always helpful to kind of share, negative 0.0265 plus 0.0312, and that leaves me with 0.0047. Good. What I would suggest is make sure your values are written exactly correctly. Negative 0.0265 and then 0.0312. When I divide, so I have 23.5 divided by 0.0047, I get that B is 5,000. Now, think back to what B represents. Always refer back to your chart. Always, okay? This is a habit I want you all to be used to by now, especially since we've done this all in Chapter 3 as well. Go back to your relationship. B is here as the principal for account 2. What that means is we know how much money was invested in account 2. So we can say account 2 has $5,000, right? I'm going to write my answer, but I know that I don't know what is in account 1 yet. I'm just setting up my response. So I do know that account 2 has 5,000. Now, Claire has pointed out that if account 2 has $5,000, then account 1 has to have what's left over, which is $3,000. Beautiful. Also note that account 2 wasn't account 2 at the 3.12% rate, so we may want to say at 3.12%, just to point out that we know the rate for that account. For account 1, we know the rate is 2.65%, so that's our answer. Now, Claire did this right away by saying, well, I know that a person invested $8,000 total. If I put $5,000 in one account, then that means I have $3,000 in the other account. What we can do, if you would like, is we can actually take this value, B is equal to 5,000, and plug it into our principal equation. Our principal equation is A plus B is equal to 8,000, right? But we know that B is 5,000. So we have A plus 5,000 is equal to 8,000. Subtract, and we find that A is equal to 3,000. So that's another way to think about how to solve. Now, just to answer this question, so Claire, notice that my coefficient of my A term was a positive 0.0265. If I multiply by a negative 0.0265, that'll allow me to eliminate my A terms. But I didn't have to eliminate A. I could have eliminated B. If I chose to eliminate B, then instead of multiplying by a negative 0.0265, I would have multiplied by a negative 0.0312 to eliminate my B term. So that part is completely up to you as well. Remember, we're just applying the idea of elimination. How do I cancel these two terms? Well, to cancel them, they have to be opposites. Let's do it again, and I think you'll find it to be really helpful. And as always, remember, you're distributing to all the terms in your equation. Let's try it again. Number 10. Taekwon invested $30,000 for 1 year in 2 separate accounts paying 3% and 4.1% annual simple interest. If Taekwon earned a total of $1,091.73 from the 2 investments, how much was invested in each account? Let's set up our chart once more. So we have principal, rate, time, interest. Let's set up our 3 rows below this. Account 1, account 2, and total. Perfect. Account 1, account 2, and total. So let's start this again. Taekwon invested $30,000. That is total principal. So investment is principal. So we're going to put $30,000 in the total principal. Keep in mind, you don't know how much was invested in each account. That's why it's asking us how much was invested in each account. That means we can say the amount invested in account 1 is A, and the amount invested in account 2 is B. Next, we are told that the rates for the 2 accounts are 3% and 4.1%. As a reminder, if it helps, take your 3, divide by 100, you'll see that it's 0.03. And then take your 4.1, divide by 100, and it's 0.041. Okay, always move it 2 places to the left. Let's go ahead and write down our rates in our chart, 0.03, 0.041. We recognize that the time is 1 year. It will always be 1 year, so we can leave that as such. And then we're told it was that Taekwon earned a total of $1,091.73 from the 2 investments. You can only earn interest, right? You can accrue, you can earn interest. So the total interest is $1,091.73. Okay, so the interest from account 1 is going to be your principal times your rate times your time for account 1. So your interest is going to be 0.03A. Your interest for account 2 is 0.041B. As a reminder, you have 2 equations here. You have your principal for the first plus the principal for the second equals total principal, which means that your first equation is right here. Your second equation is the interest from the first account plus the interest from the second account equals total interest. And that equation is here. So let's go ahead and write both of these equations carefully. A plus B is equal to 30,000. And then we have 0.03A plus 0.041B is equal to 1,091.73. I know I promised that I would use substitution, but because there was a question on this elimination, I'm actually going to use elimination once more. So if I want to eliminate A, Claire, would you go ahead and in the chat type in what I have to multiply my top equation by so that I can eliminate A? Go ahead and type that into the chat. Yes, Claire, that is perfect. So you're going to take the entire equation, put it in parentheses, and what you're going to multiply by is a negative 0.03. Good. That's the value you're going to multiply. Don't multiply by an A also, just a negative 0.03, because when you distribute, that'll give you the values that you're looking for. So let's check it out. Negative 0.03 times A is negative 0.03A, you see? Negative 0.03 times B is a negative 0.03B. And then negative 0.03 times 30,000 gives us negative 900. We're very careful with all of our signs as we move through. You have to be careful with your decimals and you have to be careful with your signs. Errors can happen in either of those two places. The second equation can stay as is, so we're just going to write it directly underneath. And we're going to combine the two equations and see what happens. Negative 0.03 and positive 0.03, they eliminate each other. Now in your calculators, carefully punch in negative 0.03 plus 0.041. That'll give you 0.011b is equal to, now we have negative 900 plus 1091.73. So you should be left with 191.73. Divide both sides by 0.011, and we're going to find how much was invested in account B. So let's punch that in. 191.73 divided by 0.011. We see that in account B, we have $17,430. Okay? While I write out the answer, I would like you to tell me how much was invested in account A. So I'm going to say account 1, account 2. So B represents account 2, which means in account 2 we have $17,430. Note here that that was at the rate of 4.1%. So I'm just going to note that it's at 4.1% so that everyone knows the rate in which it was invested. What we have left is to figure out how much was invested at 3%. So Claire says, well, that's a piece of cake. If you have $30,000 total, right? So let's take your $30,000 and you know that you invest $17,430 in the second account, well, take that much away. If you subtract that much, you're left with $12,570, which is exactly what Claire has pointed out. Beautiful work. So we can say here that account 1 is $12,570, and remember, that's at the 3%. So your answer would be as follows. What I'm going to illustrate to you is, in case you're wondering how in the heck I got the 17,430, rewrite your principal formula, A plus B is equal to 3,000, and you know what B is. B is 17,430. So A plus 17,430 is equal to 30,000, and then of course subtract the 17,430. If you subtract those values, sorry I had to turn that, if you subtract those values, you get that A is equal to 12,570. Okay? Beautiful. I know that we used elimination again, and I'm seeing, you know, Doc, Hannah, you all love elimination as well. So keep trying this. I think that you'll end up noticing that when you have standard equations, these are both in standard form, that elimination is just going to be such a great way to actually solve. What I'm going to do right now is I'm actually going to give you time to do number 11 completely on your own. So I'll give you a few minutes, like maybe about 5 minutes, because I know it's a lengthy process. So Kyle invested $7,000. Part at 8% simple interest, and the rest at 5% simple interest for a period of 1 year. If he received a total annual interest of $476 from both investments, how much did he invest at each rate? 5 minutes starting now. All right, let's take a look. I see answers in the chat and they all look fantastic. You're all agreeing with each other. So let's see if my work agrees with yours. Excellent, Ria, thank you. And as you find the answers, please share that in the chat, even though I'm going over it right now. So again, we want to set up principal, rate, time, interest. So we need Sorry, this is getting sloppier. Account 1, account 2, total. Account 1, account 2, and total. We know that Kyle invests $7,000. That's his total amount. Part at 8%, so that's 0.08, and the rest at 5%, that is 0.05 for a total of 1 year. The total annual interest was $476 from both investments. So how much did he invest at each rate? We'll call this A, we'll call this B. So the interest for account 1 is 0.08A, and the interest for account 2 is 0.05B. So hopefully you all had this set up correct, and you'll notice that your two equations are here. So I am going to use substitution this time, so A plus B is equal to 7,000. I am going to subtract B. Again, you don't need to do this. I just want to show you some options. And we find that 7,000 is equal to, that A is equal to 7,000 minus B. At this point, I'm going to write my second equation, 0.08A plus 0.05B is equal to 476. But we know that A is 7,000 minus B. So I'm going to make that substitution in place of A. So let me show you what we do here. So we have 0.08 times, and then we're going to write 7,000 minus B, plus 0.05B is equal to 476. We're now going to distribute. Thank you, Kayla, for specifying the rates for each of those accounts as well. That is perfect. So we are going to distribute here. We have 0.08 times 7,000, and that's going to give us 560 minus 0.08B plus 0.05B is equal to 476. I'm going to combine these two. So negative 0.08 plus 0.05 is actually going to give me negative 0.03b. Not a big deal. So we have 560 minus 0.03b is equal to 476. I'm now going to subtract the 560. So you're probably thinking, whoa, you have a negative value here. I thought you're supposed to have positive amounts of money. Well, wait, we're not done solving. Hold your horses. So we have 476 take away 560, which is also negative, and negative 84. So then you notice when we solve for B, we actually have to divide by a negative 0.03. These cancel each other out, so we have B is equal to, remember, a negative divided by a negative is a positive. And even if you punch this into your calculator, negative 84 divided by negative 0.03, you will get a positive 2,800. So if you said 2,800 was invested in the account B, which is at the 5%, you did amazing work, and that is perfect. So to recap how we get the remainder of this, we can say A plus B is equal to 7,000. And we know that B is 2,800, so I'm going to replace B with 2,800. And I'm just going to solve. And we'll figure out how much was invested in the other account. We subtract the 2,800. And we get that A is equal to 4,200. Beautiful. So now we're going to write our answer. So account 1, which is A, is 4,200. That's at 8%. And account 2 is 2,800. And that is at 5%. Beautiful work. I'm going to go ahead and draw my cloud. I like using the clouds. Plus, it's hard to draw the circles, right? Thank you, Kayla. That is fantastic. That is what I love to hear, okay? I definitely love to hear that. Now, you could, I'm going to give you an option, okay? I'm about to give you an option here. You could do number 12 and work on that right now, or you can try a challenge problem, okay? Yeah, I love elimination too. especially when they're in standard form like this. It just makes a lot more sense. I'm going to try and push you in a direction that makes you uncomfortable. Yes. Okay? So I'm going to let you see number 12, right? And then I'm going to show you the challenge problem, and you pick your own adventure. Okay. Marty received an inheritance of $60,000. Ooh la la. She invested part at 7% and the rest at 10%. Her total annual income from the investments was $5,100. Find the amount she invested at 7%. That is your first path, right? If you're going to choose your journey, that's your first path. If you want a challenge problem, take a look at this. You invest 4 times as much money in one account as you do in another account. The total interest earned was $470, and the rates for the accounts were 5% and 3.5% respectively. How much was invested at each rate? All right, choose your journey. Okay, so you will take both of those problems home. Take number 12 home and maybe try the challenge. See how it goes, okay? Get creative with it. Think back to Unit 3 and how we would work with these kinds of statements, this kind of algebraic interpretation, okay? I am going to email you the correct solution for both of these. I'll actually show you the work for the challenge problem, and then I'll type in the answers for number 12, and I want you to work towards those answers. All right, wonderful work today, and I will see you all tomorrow for a continuation of our Unit 5. Have a good day, everyone. See ya.